Thank you very much, Patrick. Thank you for this presentation. Thank you for your patience as well for the test with the video conference. We're gonna follow with Professor Lee from HKU. If you like to join us, we're gonna load your presentation straight away on the computer. And if you like to stand there for the video and introduce yourself a little bit and the project you are having at the Hong Kong University. Okay. Thank you very much.
Thank you. My name is Victor Lee. I'm from the University of Hong Kong. At the University of Hong Kong, we have a multidisciplinary project called ICEE, which stands for Initiative for Clean Energy and the Environment. And this project involves faculty members from 3 faculties, include engineering faculty, science faculty, architecture, and also some researchers in the Kaduri Institute, which is on policy development. So there is about 20 professors involved in this project. So today I talk about one of the project, which is on smart grid. Next slide, please. So this is the outline of today's talk. I'll say a little bit about smart grid. Then I'll talk about sensor and actuator network for smart grid. What are the challenges of SANET, and introduce some of the research at Hong Kong U. Next, please. So, what makes a grid smart? Okay. Well, basically, a grid is smart because it is self-adaptive. And if you look at this picture here, the grid has the capability to perform sensing using different sensors. The sensing allows you to find out what the state of the system is in terms of supply, in terms of demand, and in terms of the delivery capability. Based on the sensor data that is collected, then we do some prediction based on some kind of prediction algorithm. And then we do some kind of distributed control and management algorithm. And then we adjust different parameters in the system. For example, turning on a switch, turning off a switch. The key basically is ensure that in this grid, the supply and demand is balanced. So that's the key of a grid, is to balance the supply and demand. Next, please. So my background is actually in information technology. So the idea is, how do you transform the traditional electric grid into a smart one using such information technologies as intelligent sensors, advanced communications, and system control and management algorithms. Next, please. Perhaps the most important benefit of the smart grid is that we can increase the penetration of renewable energy sources. Renewable energy sources such as wind power and solar power, they are good in the sense that they do not generate carbon dioxide emission in the atmosphere. The only problem is they are not very stable in the sense that, for example, suppose you have solar energy. When there's no sun, then you don't have electricity, which is a problem for the smart grid because, as I said earlier, we need a balance of the supply and demand. So solar energy is very intermittent. So is wind energy, very intermittent. So we want to be able to ensure that the supply and demand is balanced using smart grid technologies. Next, please. So this is a picture of a smart grid architecture. So basically, at the bottom, you have distributed sensing and actuation. You also have a module on communication and networking. And then we build the application and decision support system on top of these modules. Today, next, I'm focusing on this particular module, which is the distributed sensing and actuation. Next, please. So in particular, I talk about the sensors and the actuators. What is a sensor? A sensor measures and it converts some kind of physical properties into electrical signals or data. For example, you may have a sensor for energy flow, like the voltage, the current, the frequency, and so on. You have a sensor of the environment, the temperature, the humidity, the luminance or the lighting condition. For example, you may have a street light which automatically dims when the luminance is high. So when the sun comes out, then you don't need to turn on the street light. And you also monitor the working condition of the grid in terms of, for example, the temperature of the oil in the electric power generators, the pressure, the speed, the position or the sagging of the transmission lines, for example. So these are all sensors. Next, please. So this is a picture of some of the sensors that is available. This, for example, is a temperature sensor. This is a current sensor. You put the wire over here and then you just clip it. You can measure the amount of electricity that is flowing in that piece of wire. There are motion sensors and so on. Next, please. An actuator, on the other hand, it actually executes control decisions. It converts electrical signals into physical phenomena, such as, for example, a display or actions. For example, a breaker or a switch. For example, in energy flow, you may have a breaker, you may have a dimmer, you may have a valve, brake, motor, and in terms of user interface, you can have display, you can have alarm, so a speaker goes off. Next, please. So these are some of the examples of actuators. This particular one is a energy in-home display that we actually developed at Hong Kong U. You can have valves and motors and so on. Next. So when you put together these devices and connect them together using a communications network, then you have a sensor and actuator network. So we call it a SANET. Next. So if you look at the grid, so basically you have the power supply, so you can have sensors on the power supply. You can have sensors on the demand. For example, you have a smart meter in your home that measures the amount of electricity that is being used. Then you monitor your transmission network, okay, to make sure that the capacity is sufficient to transmit the electricity. The key here is to balance the supply and demand of the electricity. Next, please. So if we want to have a very good smart grid, so what are the challenges? Okay. So the challenges is that we have a system which is heterogeneous and it is distributed. We have a highly dynamic system. The supply, especially if you have renewable energy, it fluctuates a lot. The demand also fluctuates a lot. You have to deal with the problem of scalability because you're talking about a system with millions of devices. You're talking about millions of sensors. Okay. So a solution that works when there are 5 sensors will not work when you multiply it by 1,000,000 times. Okay. Then you have the capability of, or the desire to have the capability of autonomous management. Because things are happening so fast, you may have to make a decision within a millisecond. So you don't want to always rely on a human operator to make a decision. Okay? So you want to have the ability of the system to make decision automatically. You need to have the flexibility so that you are backward compatible. For example, in a communication network of the existing power grid, there's something called the SCADA system. The SCADA system will not work in a smart grid because it's not enough to support the number of messages and the volume of traffic that is expected. So the question then is, what do we do? Do we just throw away the SCADA system or do we try to upgrade it? So you want to be flexible to accommodate all these different possibilities. And obviously, we want to monitor the network in a very cost-effective fashion. Next, please. Yes. So I'm a professor, so I do research. So after looking at these challenges, then I say, how do I address these challenges? And these are some of the research that we are following at Hong Kong U to address these challenges. Next, please. So the first thing that we come up with is something called a pervasive service-oriented network called PERSON. The idea is because you have a heterogeneous distributed system, you have a highly dynamic system, it is a very complicated animal. So the question is, how do I attack this very complicated problem? So I divide this problem into layers. I decompose the very complex problem into different components. And I come up with a general framework so that I can seamlessly integrate the different actors in this smart grid. So the principle is decompose this complex system into different layers with some loose coupling between them so that I can focus on one layer at a time instead of looking at the very complicated system together. So this addresses these challenges. Next, please. Then, in order to address the dynamics in the smart grid, we have something called context-aware intelligence control. So context-aware, for example, when I walk into a room, because of the special tag that I'm wearing, then the room knows that they want to turn on the light. The room knows that when I walk into a room, I want to have 23 degrees centigrade. So adjust the air conditioning accordingly. So depending on the situation, it's customized to the individual situation. And this is to enhance service availability, convenience, efficiency, and security. Next, please. Another problem that we address is that of compressive sensing. The idea is because you have these millions of sensors in the network, so if you have all this sense information being transmitted in the network, you will put a major loading on the communication system. So the question is, how can we reduce the number of messages that is being sent in the network? And we use the concept of compressive sensing. Next, please. Which is probably best explained by some pictures. For example, here is a picture of a wind farm. There are different windmills. And one possibility is you can have a wind sensor associated with each windmill. And the wind sensor measure the wind condition and then through the communication network send the information back to the control center. However, we realize that the wind conditions in adjacent areas may be similar. So what that means is it may not really be necessary for you to have a sensor for each windmill. So you may have one sensor for the whole vicinity and then just collect the information and send back to the controller. Next, please. Similarly, we can exploit the data correlation in a time domain. Instead of sending the energy consumption information every second, every minute, we can send it at a longer period of time depending on the fluctuation that is expected in the demand. Next, please. And finally, you have to make the devices. You have to make the sensors, you have to make the actuators. So we want to make devices that are no power consumption, compact, and low cost. Next, please. All right, so finally I want to talk about an application that we have developed. This application is called the Home Energy Management System. So the smart grid consists of the power generators, the distribution network, and the consumers. So this particular application is at the consumer. The idea is to monitor the usage of electricity at the home. So the idea is we develop a system based on the HKu communication technology. HKu is a wireless communication technology, not very different from the Wi-Fi technology that you're familiar with. but it is a shorter range and it uses less energy. Okay. So what you have is you have a ZigBee area network, and we make devices that have ZigBee controllers that allow you to send the information to a ZigBee home control center. Okay. The ZigBee home control center also have a ZigBee internet gateway. So they allow you to communicate with the internet. And of course, once the data is on the internet, you can get the data from any web page or from your iPhone. Next, please. So this is a prototype of this energy management system that we have developed. We have a display and power meter that measure the amount of electricity that is being used. You cannot see this very clearly, but there are different zones. So you have up to 6 different zones. Zone 1, for example, may be a living room. Zone 2 may be a kitchen. So you can monitor the amount of electricity that is being used in the different zones. These are devices that we make to monitor, to sense the amount of electricity that is being used. And then these are the software that were developed to show the amount of energy consumption. And you, for example, you can also have a historical comparison. I can tell you, for example, in your bedroom, what the electricity usage is for the past 3 months. Okay. And you can also access this information using the web. And of course, you can use the web as an interface to turn on and turn off your appliances remotely. Next, please. And with that, I will stop. Thank you.
Do you have any question for our speaker tonight?